good afternoon or good evening, depending where you are. We are honored to be able to participate in the Pulsar Hackathon. Thanks for providing opportunity to show our ideas. We are working on some Pulsar enhancement to support Hyperscale topics and clients in Pulsar cluster. Before I show the details, please let me introduce the team. The first member is Lin Lin, worked at Chen Cloud, mainly responsible for a message system, and he is also a Pulsar committer. And the second member is Chen, working at Beagle as a lead of big data department, and he is also a Pulsar committer. Finally, this is Penghui from Stream Native. For our cluster, I want to support millions of topics. The metadata service might become a bottleneck since we need to maintain host topic metadata in the ZooKeeper. ZooKeeper is a good component, but if the ZooKeeper becomes the bottleneck, this will affect the Pulsar cluster stability. And if you have too many producers in the cluster, but the traffic of each producer is very low, so this will introduce too many small entries in bouquet. This will also affect the bouquet throughput. So the first one is we are trying to find a solution to move some data to system topic instead of maintain them in the ZooKeeper. The first one is we are introduced the system topic in Pulsar. But currently we are not support the snapshot isolation. The first one is try to support the snapshot isolation to avoid write skill, so that it can provide the ability to able to maintain more data, more metadata in the system topic. Yeah, for the implementation, we need to add a version field into the data in the system topic, and the broker will check the version in the data. If the update, if the modification is not based on the latest version data, the broker will reject the request. Another one is move the bundle states to the non-persistent topic. Currently, the load balance mechanism, all the load states data, including the broker load data and the bundle load data, will be written to the ZooKeeper, and the broker will read the broker load data from the ZooKeeper at a specific interval. But if there are too many topics and bundles increase to millions of topics, this will brings large amount of load states data right into ZooKeeper, so that the ZooKeeper might becomes the bottleneck. So in our design, we are try to use a non-persistent topic to maintain the bundle state, so that we can avoid to use ZooKeeper to sync the data, sync the state data between different brokers. Why we use the non-persistent topics? The first one is the broker load state or the bundle load state. It's no need to be persistent, and so they will be referenced with time going on. And the second one is storage of state data need to be auto-scaled as the amount of data increase. So the Pulsar non-persistent topic is more suitable for this situation, and the non-persistent topic can provide a real-time load state update. So this is some details we will work on this feature. The second one is we introduced a new feature named the topic level bench. For the current implementation, we are support the producer level bench. So as the illustration, if we have 3 producers, there are 3 messages in producer 0 and 2 messages in producer 1, and one message in producer 2. And if these 3 producers send messages to the topic, these 3 messages of the producer 0 will benched as in one batch and sent to the topic. So if the broker one set to a bench with 2 messages, and the producer 2 send a bench with only 1 messages. So if we have many producers, you can see there are only a few messages in a bench. So this will introduce more and more small entries in the ZooKeeper. So the topic level bench is the messages will batched at the topic level. So if the 3 producers send messages to a topic at a interval, the messages will be benched in a single entry. So one entry will contain messages from the different producers. So this can work well with many producers. So the approach is the broker only compose the producer batches into a single entry, and the broker dispatches the multiple producer batches to the consumer. So we only need to add metadata named the batch offset to indicate how many producer batches in the entry, so that when the broker dispatch the entry to the consumer can split entries based on the batch offset. Since we have introduced broker entry metadata, so it's easy to implement based on the broker entry metadata. We only need to add a new field in the broker entry metadata named the batch offset, so that we can dispatch the broker actual metadata to the a consumer. The consumer can split the client batches based on the batch offset. With the topic level message batch, especially for the cases with many producers, this will reduce the entry request from the broker, and reduce the entries and indexes in the booking, and it will improve the write and read throughput for if the topic has many producers. Here is example to show how the broker level batch works. For first one, we have a producer, but I have disabled the client side batch to simulate the client with a very low throughput, and we have our consumer to consume the messages from the topic, and then we send some messages and print the message ID. So due to the broker batch the several messages into a batch, so the producer will get a batch message ID even though the producer disabled the batch. Yeah, so here is the result. The producer publishes 10 messages, and this is the message ID returned from the broker, and here is the consumer consumed from the topic, which is you can see the message ID is the batch message ID. Okay, thanks. This is all about the ideas we want to share through the Pulsar action. Thanks.